In today's podcast, we're going to look at entropy and also spontaneity. In order to talk about the concept of entropy, we need to look back at the laws of thermodynamics, which you've probably gone over before, but just a quick review. The first law is that energy cannot be created or destroyed. We sometimes call this the law of conservation of energy. It can be converted from one form to another. And then the second law says that in any spontaneous process, there's always an increase in the entropy of the universe. But what does that mean? What does entropy mean? So entropy is sometimes defined as a measure of randomness or how disordered something is. And when we measure it and talk about it in thermodynamics, we use the letter S to abbreviate it. And the units that we use are joules per mole Kelvin. And when we try to understand this idea that there's always an increase in entropy, you'll often see in textbooks that they'll use the example of a teenager's bedroom. So if we think about that you have lots of things that have to be kept in a room, and they all have a specific place, the probability of all of those things being in their exact right place all at the same time is very low, right? So entropy is kind of related to probability as well. The probability of things falling just anywhere and having all kinds of possible arrangements is much higher. And so generally, it's much easier for things to be in chaos than for things to be in an absolute specific spot. So when we apply entropy to some things in chemistry, if we're looking at states of matter, for example, we would say that a gas has much more entropy in it than, or possesses more entropy than liquid or solid. And if you think about it, in a gas, you have no intermolecular forces present. All the particles are acting independently. There's lots of different ways they can arrange themselves. There's lots of motion. Liquid, those particles are just slipping past each other. There's still some intermolecular forces holding them in place. It's a lot more ordered. A solid is going to be very ordered. The particles are all going to be kind of lined up in if it's an ionic solid anyway, it's going to be a lattice structure, very ordered. Not much possibility for the motion of those particles or for them to move around into a different spot. So there's much less entropy possessed by a solid. If we're talking about something dissolving, when a solid dissolves, those particles are much more spread out, have much more possibility for motion, much more possibility for different arrangements. And so the entropy of a dissolved solid is much greater than the entropy of the original solid. So what I want to do is take a look at some reactions and predict the delta S for them, for the change in entropy for that process. And basically, if delta S is greater than 0, so if it's positive, then that means it's increased in that reaction. If it's negative, that means it's decreased in that reaction. So I'm going to do the first one for you, and then I want to have you pause it and work on some on your own.